Hi friends, this is Praveen Patil, a math teacher for you all. So today I'm going to discuss a very easy and interesting concept is called the determinants. So before going to the main heading, determinants, I'll just brief out what is a matrix. To define a determinants, we need a matrix, especially the square matrix we need here. So then, matrix. So what is a matrix? Matrix is a systematic arrangement of numbers in a rows and a columns. Matrix is a systematic arrangement of the numbers in a rows and a columns. So then, first I'll write the numbers here: 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here this is called as the row, right? And this is called as the column. Here this is the first column, second column and the third column. Similarly, this will be a first row, second row and the third row. So matrix is a systematic arrangement of numbers enclosed or within a brackets and arranged in a rows and columns. So the horizontal is called as a row and the vertical is called as the column. So here the number of rows, if is equal to the number of columns, then it is called as a square matrix. So then if we have a look into a square matrix, if number of rows is equal to the number of columns. Very simple. Here, what are the number of rows here? First row, second row, third row, means number is 3. 3 rows are there. Then similarly, first column, second column, third column means again 3 columns. And this is what we call it as a order of a matrix. If first how we write here, it is number of rows into a number of columns is called as the order of a matrix. So here we always use a matrix to denote by a capital letters of our alphabets. So A equal to a matrix, which is arrangement of numbers in rows and columns. Then the number of rows into number of columns is called as the order of a matrix. If for a square matrix, if the number of rows is equal to the number of columns, then such matrix is called as a square matrix. And if you take the 2 cross 2 matrix, so the number of rows, this is a row, this is a row. There are 2 rows into the 2 columns. This is what we call as a column, right? Then it is the 2 cross 2 matrix. This is a very small recapitulation for a concept of a determinant. So I'll go to the definition of the determinant. So determinant is just a mapping from set of square matrices, or we may say the matrix, to say real number or a complex number. So here this is a unique one, means whatever the number, whatever the square matrix if you put here, you will get a unique number, either it is a real number or a complex number. Means for a determinant, and moreover determinant is denoted by this. If this A is a matrix, then determinant is denoted by D in this form or det of a A. determinant can be, it's not a modulus, remember this one thing, it's not a modulus, it's a determinant of A, means A is a matrix. The determinant like this we can denote the determinant also. Now this is a map from set of matrices, that to set of square matrices to go into a, to get a real number or a complex number, and it is a unique. Very simple. Matrix no value, whereas the determinant has got a value. That is the most basic difference between matrix and the determinant, because it uses a, especially the determinant uses a square matrix to get a real number or a complex number. So this gets you the unique value. Therefore the determinant has got a value, whereas the matrix don't have any kind of value. This is the basic difference between matrix and the determinants here. And the most important thing in this determinant is expansion of a determinant. Very simple and important also for all kinds of exams. For example, we take the heading expansion of a determinant. So now I'll take a 2 cross 2 determinant, 1, 2, 3, 4. Now I want to expand this determinant. Very simple. Multiply this diagonal elements, that is 1 into 4. Subtract non-diagonal elements, that is 2 cross 3 or 2 into 3. Answer is 4 minus 6. So the answer is minus 2. When you simplify this, you will get the minus 2 as the first answer. This is how we need to expand the determinant here. Diagonal elements first, then a non-diagonal elements. Then you need to subtract them as we have done here. This is for a 2 cross 2 matrix. If we go for a 3 cross 3 matrix, so I'll take a 3 cross 3 matrix here, determinant, sorry, 1, 2, 3, 2, 4, 6. Any matrix, generally I'm taking small numbers, right? And now the expansion of the determinant. Before going to the expansion of determinant, one should know the signs here. So here it is a plus sign, minus sign, then the plus, minus here, plus, minus, so plus, minus, and the plus. So it's very important to know this signs for the determinant expansion, especially for a 3 cross 3 determinants. So you can go through this row, you can go through this row or this row or any column. You can go through this column or this column or this column. There is no worry, but only the thing you need to follow this signs here. So let me start with the first row. This is the first row, second and the third row. I'll start with the first row. Then the signs will be first elements. So I write like this here. Then it is a plus, so it's a plus. Then take a or leave this. If you're writing for a 1, then leave the column and the row. So leave this column and the row. Whatever left you have left here, that is write in a determinant way. It is 4, 6, 7, 8. Then next term it's a minus and the element is 2. Now you leave this column and the above row. So what you are going to get? It is 2, 2, 6, 4, 8. 2, 6, 4, 8. Okay, then last one plus using this sign 3. Then it is leave this column and the first row. Only elements left 2, 4, 4, 7. 2, 4, 4, 7 here. So now you expand the 2 cross 2 determinant. So 1 here, diagonal elements. 4 8s are 32 minus 7 6s are 40 minus 2 outside, 2 into 8, 16, 4 into 6, 24. Then last plus 3 here, 2 into 7, 14 minus 6. Just expand. 1 into minus 10 minus 2 into minus 8, then plus 3 into minus 2. So the answer here I'll write minus 10, then plus 16 minus 6. So the answer is 0. So 0 is also a real number. So here what we do, we expand the 3 cross 3 matrix in this form. So this is what we call the expansion of a determinant. Hope you will get some more examples in my next video. Thank you for watching this video. Thank you.